This video has been sponsored by me, Steamhead, and what I always forget to say is the idea is that you can visit my online shop and buy stuff that I've made. I get so involved in designing and making Florence that I keep forgetting about the business side of it. The featured product this week is the Net Throbwell Kitchen Timer Kit. It contains everything you need to construct your very own working steampunk machine. This is the one up in our kitchen that we use all the time. To switch it on, you click this brass key. A lamp illuminates, a flickering candle lamp. You then set the time that you require the cooking to take, down from an hour to less than a minute. This mechanically is driven round and the gears turn. When time's up, you get a warning from a real working air horn. The kit contains everything you need, you don't need any special equipment, and if you're interested, all the instructions are on my website at steamhead.co.uk. The perfect gift for someone who's always wanted to make their own working steampunk machine. Right, on with Florence. Right, the first job is to take the Arduino Uno out and replace it with an Arduino Mega. Simply because, as always, I've run out of pins, and the Mega has so many more. There's 52, 53 different inputs and outputs and things, so that's great. And what's really impressed me is so brilliant, because I was thinking, I've put these screws in now that hold the Uno in, and now I'm going to be left with empty holes. And they have so thoughtfully, on the Mega, made holes in exactly the same position, so you can just unscrew an Uno and screw in a Mega. Right, the Arduino Mega is installed, the screws lined up perfectly, fits in the little slot that I managed to hammer out of the base of it. Now I'm going to wire up the phonograph speaking system motor. I'd got this stuff. I bought this ages ago because I saw it online and just thought this looks amazing. So around the outside there's two fibres, some sort of fibres that are metallic and give it that lovely old-fashioned glinty look. But in the middle, if hidden away, is this amazing, some sort of chainmail. It's got to be classed as chainmail because it's made of individual little links that are joined together in a tube. It's absolutely amazing, and it's really quite rigid. You can't squash it very easily. There's room in the middle of this centre part for a wire, loads of room actually. And this will look lovely, so I'm going to work out how to fix that on there, possibly with some heat shrink tubing, one there and one there, and then they can be visible or whatever, and take the wires where I need them to go. That's brilliant. So here's the engraved bit. You can see it's engraved about halfway through, which is great, to allow the wires to meet up with two 5mm holes I'm going to drill in this end, and then that should all fit over the end once it's sprayed up and look really good. If you remember back to the other day, which was probably about 30 seconds ago, possibly a couple of hours ago on this video, right, we're going, I needed to work out how to connect this little motor up. So I cut that out of 10mm acrylic and I sprayed it with this lovely spray paint, very textured and metallic. This is called, by Rust-Oleum, that's Rust-Oleum cast bronze, and it gives a really nice effect. And then I've drilled two 5mm holes in the end to accept the ends of these bits. So there we are, we've got the two metallic pipes glued in. Bit fiddly, but the wires have gone through the middle of these lovely metallic tubes, and there they are. They've come out on the inside, so I can now solder them onto the motor, stick this into place and see what it looks like. Also sprayed some of these cable clips with brass paint, so they look like cable clips painted with brass paint. I think it's the 2mm that or something gives it away. Never mind, I think they'll be okay. What I need to do is have some way of fixing these little pipes in place. So there's one I prepared earlier. I think that'll be fine. It's going to be so buried amongst all the other stuff that's going on, it's not going to notice. So I think I'll keep them. Not bad, but unfortunately, as sometimes happens, there's a speck of glue that obviously didn't get hoovered off when I hoovered it. On this bit, there's two other little specks of something or other. If I was building this for someone else, then I would sand them off and respray them. But as it's for my machine, and there's going to be so much going on around these things, it's not going to notice, so I think I'll leave it. So just like the phonograph drum cylinder, the bearings just push into the front and back. And what I'm using as a shaft for this is in fact an M4 screw. So it's just the right length, and because the thread isn't going to theoretically rub on anything, all the rotational support's going to be given by the bearings. It really doesn't matter. It's just going to stick far back enough to fit into that with the aid of a washer. Lovely. Just when you think you've got it all sorted out, it's hitting something, and it's because these screws are slightly longer. Originally they were not countersunk, so they didn't stick through far enough, and they're now hitting the speaker at the back. So I take it all apart again and grind them down basically, or saw off the end bits that they don't stick out so far. So here we are. I've cut the backs off them and cut them really short, because in effect, as this is smothered in superglue and is now held together just by that, the screws aren't really necessary. They're purely decorative, so I'm just going to glue them in to the holes with superglue. They don't need nuts on the back, and that will reduce the amount this sort of waves around and the likelihood of it hitting other people even further. Okie dokie. Oh, they said, just put it back in. Spray it and put it back in. It'll all fit like it did before. So I put it back in once, and the screws hit the speaker. Took it out, cut the screws off, put it back in, spun it round, and it wobbled. Took it out, and I've adjusted the middle. It's because I disassembled all this, and this front piece and the back piece, the two bearing holders, are separate. They're held together with these 3 screws, and they were slightly misaligned, but now, in your face pulley, it's only taken me about an hour and a half to get this fitted in, but it now misses the speaker. Let's spin the beautiful spinny thing again, and it doesn't hit anything, and it's silent and it's beautiful. It's relief, so I can get on and hopefully put the other pulley assembly in now. Let's give it a go and see if I can let some smoke out of the Arduino. Hopefully not. Hopefully Florence will perform as before, but with the addition, interesting hairstyle, with the addition of the phonograph turning. Look up and speak. That's nice. Lovely. I'm happy with that. An interesting little side point here is the picture looks like it's flickering slightly because the Arduino initially with pulse width modulation outputs, which are controlling the brightness of the LEDs, at 480 Hertz I think, so they're switching on and off 480 times a second, and because it's high definition the camera is actually picking that up. Tell you what, talking about hiding things away, the motor is barely visible, the pulley is barely visible, and the bits at the back are barely visible, and the phonograph is barely visible. Thing is though, less is more. It's nice that this is reminiscent of some sort of Victorian invention where they didn't necessarily want to have everything on show. They were constrained by the size of a cabinet, what they could fit inside. So I think it's okay. I may need a little bit more illumination, but if you're looking at the machine and you look over there, you can see the pipes that spent hours and hours and hours fixing to the motor that you can barely notice. Oh, they're nice and shiny in the bottom. Here's the list of instructions that gets Florence to move, the animator basically. And what I've done, if I can try and move the mouse, and for the, wherever it says random mouth, because at the moment she just moves her mouth up and down just to indicate that she's speaking, what I've done on the random mouth function, I've said analog write 7, pin 7, which is the motor that I've just added that moves the phonograph, to 200, which is 255 is full power. So 200 is a little bit slower, just make the motor and things last longer possibly, don't know. So it does that, then it waits half a second, because it's in milliseconds, 500 milliseconds, half a second, then moves the mouth, and then after the mouth has finished moving, waits half a second, and then analog writes to 0, which means that the phonograph motor stops. So the problem with moving a stylus backwards and forwards in a regular fashion is I need to get, I think the cam is the best way forward, and I need to slow it down much more than the phonograph is turning. And the best way to do that in a small space is with a worm drive. Worm drives are amazing. Normal gears, if you have a big gear, say you've got 40 teeth, driving a smaller gear with 20 teeth, the smaller gear is going to go twice as fast and half the power. Whereas with a worm drive you count as one tooth, which is so strange because it has really just got one spiral tooth. So if you've got one tooth, a worm drive driving a 40 tooth gear, it's going to be 1 to 40 ratio. Amazing things. I'm very grateful because someone gave me these gears and worm drives from an old photocopier, and I think I'm going to use this one and this one. The inside of the worm drive measures 10.4 millimeters diameter, both ends, beautifully moulded. So what I'm going to do is to draw and cut out two 10 millimeter thick plugs. I've glued the two plastic plugs, one in each end with super glue, and I've gripped it really gently in the jaws of the chuck. I've got a centre drill here, which I'm going to start off just to get it all centred. Centre drill is just really thick drill, so you know it's going to be centred properly. Not going to wibble wobble around. And that's enough for a centre drill. Once the holes started being drilled in the centre, you don't have to carry on, although you do need the chuck key, which I'll put down. Oh, there we are. Now I'm going to put a 4mm drill bit in there and drill right through. Slightly bigger, so there's 4.1mm. Wasn't enough, so I will. Now I can centre the pulley on the end and then glue it in place and move on from there. After much umming and ahhing, I thought I wouldn't bore you with watching every single little bit of detailed making of this phonograph system, the stylus. So I'd just get on with it, get it done so we can move on. I think there's this bit is explained in the last bit of the video, where this worm drive is going to turn be turned by the spring that's really driving the phonograph drum. This gear is going to be turned by the worm drive, and that's got a little crank sticking out of it that fits in a slot in this part, and this part pivots at the top, fits over the crank so that as the gear turns it moves backwards and forwards. At the bottom of this there's this funny little bit, and sticking into this funny little bit that's like a sort of diaphragm type thing is going to be a piece of aluminium, because it's all getting a little bit heavy. I don't want too much weight down here, and this is what's going to look like it's got the stylus fixed to it. So theoretically vibrations would move up here, vibrate here, and somehow get transferred over to the back of the loudspeaker here. So this sort of could work. So that's the stage we're at the moment. The difficulty has been trying to fit all this stuff in here. There's so many bits that things can hit, especially with Florence's engine as it turns. This bit's sticking right out here. So it's been very difficult trying to get everything to fit in and move, and also look like it could be reading from the phonograph drum. How very exciting, I hear you cry. Moving parts. So we've got the little motor turning the big one, big pulley turning the back pulleys which are turning the phonograph drum, and we've got an irregularly moving stylus going backwards and forwards. I see. So the spring also goes round a worm drive. Because it's a spring, it seems to jerkily pull it, which is absolutely fine. That in turn turns that gear. That's got the crank on it, and that is swinging this lever backwards and forwards, which hopefully what looks like a stylus is situated at the end of. That's not very good English, is it? At the end of which is situated a bent metal piece that looks a bit like a stylus. Now I need to cover up the Arduino and all the other wires with something that resembles a boiler of some sort of copper cylinder or something that water could conceivably be boiled in. I found this offcut from the laser cutter, which I think I'm going to use along the bottom, something like that. And now what I'm going to do, just again it's fitting things around other things, I'm going to try and make a radius here that comes out, because we've got room once above this for it to come out with a nice radius, and then straight up just behind here. It's always terribly exciting when you've fabricated something, made something up out of all sorts of scraps of plastic and bits and pieces. When you spray it and you suddenly see what it's finally going to look like. I've got the cast bronze spray, so here we go. The bits for the stylus arm are also back now, finished painting, and it's all dry, so we can fix them inside. Finally get that wretched phonograph finished. Anyway, let's just recap. Here's the pulley that comes round and can bang into the top of the stylus, and it doesn't, so that's good. And then coming down, there's this copper tube pipe, and that currently bangs into the stylus, so I need to bend the stylus in a little bit more. So there's the big wheel going round in the background. That's also driving the phonograph drum round, and it's also turning the lovely worm drive, which is slowing it down by quite a lot, turning the gear, the crank, and then moving the stylus backwards and forwards across the phonograph. Oh, by the way, I decided not to paint the worm drive and the gear simply because the rubbing action of the worm drive, the paint would have, I think, rubbed off or clogged it up and caused quite a lot of friction. And in addition, it's quite nice to have a variety of colours. In fact, it's getting so complicated, I'm not really quite sure what I'm looking at. So now what I'm doing is working out a way of fixing this cover, the boiler that I've just sprayed, into here, and so I can secure it and remove it when I desire. I say, Squire, that does look rather nice. It's so nice when you put something together out of all sorts of bits and you paint it, you finally see what it's going to look like. I'm very pleased with that, and the paint, even though it went on really thick, I'm going to glue a row of little rivets along there because this is meant to represent some sort of pressure vessel. Oh, and I had to cut out, inevitably, just like the other side, a slot to make way for the LED that illuminates the engine. And there is room to have some sort of window there with a flame, so that when you start it off it looks like the water is being heated by some sort of flame. And there's a couple of ways of doing this. With the epizooscope I used a wonderful little model candle, flickering candle effect. They're so realistic that if you look at them close up you really can't tell that they're imitation. Let's have a look at the bigger one first. This Lumiere-holic. It's interesting, not alcoholic but Lumiere-holic. I assume people who love lumens. So it's a screw in one, Edison screw. Oh, that's good. So that comes off, and inside, interesting. Inside there are 4 rings of LEDs, and they shine up into 4 separate acrylic, some sort of plastic, clear plastic tubes that have flames. Not etched into them but moulded into them. Let's just bring this up a bit and see, make it any clearer. So you can see there's flames all the way around, but none of them line up. They're all on the 4 different layers, and there's a little power supply, a switch mode power supply that turns 240 volts or whatever mains into some sort of flickering pattern. Let's plug it in and see what it does. Together. Oh, switch that on. It's not bad, is it? How interesting. So the animated effect is comprised of 4 different images, if you like, that interchange, swap between each other. It's fascinating. I'll bring it up a bit so you can see. Okay, so that's the first type. That could be interesting, although I don't like the fact that I'm wasting most of it. If I've got a window on one side, I'm not going to make the most of the rest of it. Right, let's go on to version 2, which is smaller. And also the other thing is, whatever system I use has to work off 5 volts, because that's what the rest of it is going to run off, rest of Florence, and I don't want to have to worry about having another 12 volt. That's just typical, isn't it? So now I've got a bayonet fitting. Right, give me a moment. Well, will you look at that? I thought this was going to be some wild goose chase. There's a bayonet socket on the end of a piece of wire and a moulded on plug. That's amazing. Right, we'll put this bulb in here and I'll plug it in, see what it does. That looks far more realistic. That's really nice. You've got a few little flames every now and again lifting up and floating up. That's really good. Wow, I do like that. Let's take it to pieces and see how it works. Obviously in a different way to the first one, because you can't see any lines on the flames. Okay. Is it going to come apart? Oh, yeah. Ooh, exciting. Ooh, even more exciting. So in the base we've got another little small switch mode power supply. We've got connection here, what does it say? 37.4 to 3. Don't know. I'll need to get my multimeter out and have a look at that. Ooh! Down there's a lovely little circuit with an integrated circuit in the middle and lots of other components. I'm going to switch it on again. It's exciting. This time I'm going to be careful not to touch it, because even though it's 12 volts, 5 volts or something, chances are it's not going to be isolated from the mains, and as I'm adverse to having mains voltage going through parts of me. Right, there you go. So this is made of a circular flexible plastic printed circuit board covered with these little LEDs. Means that theoretically I could unfold it and have a straight line of them. Let's have a look and see. 5.22 volts. That's incredible. So it runs off 5 volts. Possibly quite a lot of current with all those LEDs, but so the current was about 150, 170, 200 milliamps. So it looks like about 200 milliamps, which is a fifth of an amp. So it's not very much. A power supply can happily run Florence and this. I've put the flicker effect down the side by the Arduino, and I've put the side of the boiler in. And you can see actually the lovely textured paint is translucent. So what I'm going to have to do, I mean it does look lovely with the flame effect shining out through those bottom holes. So what I'm going to do is I'm going to have to spray the inside of this black. But while that's drying, I can get on with making a rather beautiful window to go in the side through which to view the burning flame. I've got the window for the flame effect designed. I've added twiddly bits. Black lines are going to cut out, and because this is 3mm acrylic, they're going to be going at a speed of 10 and the power of 40. The pieces to be engraved are going to be going much faster, 40 at the power of 15. And if I zoom in to them, you'll see, there you go. You can see they're made up of lots of lines that are 0.1mm apart, and you don't notice them because they're so close, and also the laser's 0.25, a quarter of a millimetre apart, so you just end up with something that's nicely engraved. This is a blast from the past. In fact, this one was my dad's. They're really popular in the. I'm not going to put it back together that way around because I'm just going to end up cutting my fingers. They're really popular, I think, sort of 70s. There you go, lovely. And you just store it away for next time. Brilliant. Just getting ready to fix this into the cabinet and noticed it rattled. I couldn't figure out what it was. It looked to be a capacitor, and it felt like the rattling was coming from that. Sure enough, you can hear that that's rattling, but it's not a capacitor. I think I know what this does. I was just walking through the park on my way to pick up the kids from school and thought, why on earth would you need a rattling thing? As everything these days is silicon or microscopic components or whatever. I suddenly thought, well, some sort of switch it has to be. Why would you want a switch to know which way up something was? I thought, hang on, the direction the flames move. I thought that's amazing. They've obviously taken so much time and trouble to get this, to program the little programmable chip down there, to make this look really realistic. They really didn't want to then risk it being hung upside down and having all the flames going downwards. Now I reckon that's what it is, because this is always going to be mounted up. I don't have to put the component back. If that's what it turns out to be, I can just solder a couple of wire across there. So let's try that, and I'm also going to get the one that I haven't taken to pieces and see what that does when you turn it upside down. Interesting stuff. Duh, of course this one isn't going to turn the other way up, is it? Because all of the flame effects are actually engraved. So if you turn it upside down, it just burns upside down. I'm an idiot. Right, I'm ready to assemble the window that I've created. I'll start off with a piece of laser cut 3mm ply with a hole that's slightly smaller than the one I cut in here. That's going to act as a frame to hold a piece of white 2mm thick acrylic that's translucent, so that's going to replace the original dome on the lamp, and a piece of fine mesh which I've used lots of times before. It's just so the light will show through and it just looks nice. I like the look of it. Adds another colour, you know, silver, and it's just interesting. It gives an idea that you need to be protected against something. And then on top of that, I've got the finished sprayed engraved outer window, which again is slightly smaller than the hole in the cabinet, so it'll clamp the two other bits in between them. If that makes any sense, let's put it together. Yeah, I think it wants to be a bit lower and a bit more focused actually. See if I can get this close. What about that? Ooh. Right, the flickering flame effect is glued into place and looks, well, I think it looks fabulous from the outside. That's really nice. It's just amazing. It's very clever the way they've done it. Here we are. The coat, several coats of primer, which is really thick and opaque and stops light going through, has set. That's not bad, because the flickering effect shines through the holes that I made in the bottom of the boiler. I need to glue the rivets in the holes. The only thing is that it's also shining out through, still through some of the bits that haven't got enough primer on, so I need to paint them black on the other side. Thank you so much for watching. Please remember to subscribe to my YouTube channel and also to visit my online shop at steamhead.co.uk. Something for everyone, from gauges that you can put on your own inventions through to bespoke machinery. I hope to see you next time, when Florence will definitely start speaking. At last.